Now we're shifting our focus a little bit to that leading coefficient and what it means for transformations. So we're asked to graph the function f of x equals negative 3x squared. I went ahead and made our parent function table, g of x equals x squared. Again, we should know these at this point, but I put them in here for reference. Inputs of negative 3 through 3, outputs symmetrically centered around 0. So we want to know what happens with f of x equals negative 3x squared. So first off, remember that since a is less than 0, we know that the parabola opens down. Now our inputs are the same. We're not changing our inputs. There's no horizontal shift. So we're just going to have negative 3, negative 2, negative 1, 0, 1, 2, and 3 as our inputs. So what happens? Well, our outputs are multiplied by negative 3. So if we have 9 times negative 3 is negative 27. If we have 4 times negative 3 is negative 12. 1 times negative 3 is negative 3. 0 times negative 3 is still 0. 1 times negative 3 is negative 3. 2 times negative 3, or sorry, 4 times negative 3 is negative 12. And then last but not least, we're back to negative 27. Since these two first values are so big, I'm going to go ahead and leave those off of the graph so we can get everything we need to on here. Because our graph, if we use a scale of 1, it's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So we'll use a scale of 2. Let's let each one of these equal 2, which is going to narrow our graph quite a bit, but that way we can fit it all on here. Let's start with our vertex, which is at 0, 0. And at negative 1, it's negative 3. So remember, I'm letting each one of these be 2. So negative 1, negative 2, negative 3. 1, negative 3. 2, negative 12. So 2, 2, 4, 6, 8, 10, 12. And negative 2, negative 12 as well. Now, if we compared this to the graph of our parent function, well, let's look at that on this same set of axes, just for comparison purposes. Negative 3, 9. So negative 3, 2, 4, 6, 8, 9. Negative 2, 4. So negative 2, 4. Negative 1, 1, 1, 1, 2, 4. And then 3, 9. We also have the vertex still at 0, 0. So essentially what this did was, you can't really tell without expanding it further, but if we went on, up and down, and out eventually, because it would hit the sides of the graph, you would see that this f of x is not only flipped upside down because a is less than 0, but it's also much skinnier because it's getting vertical. In this case, it's in the negative direction, but it's getting more vertical more quickly. So what that means is that when a is greater than, when the absolute value of a is greater than 0, it makes it skinnier. So it's kind of compressing the graph of the parent function.